Ready?
Yeah. IPS Podcast 5.4 Types of Matter, Pure Substance, and Mixtures.
Good.
Yeah.
All right, thank you, Eleanor. That's my daughter. These are the learning goals for Podcast 5.4. We're going to continue to reinforce the differences between mixtures and pure substances. We'll talk a little bit more about elements and compounds and how they are different. We are also going to talk a little bit more about homogeneous and heterogeneous mixtures and separate them out a little bit more too. And finally, we're going to analyze different types of homogeneous mixtures along with understanding what the differences are. So a lot of talking about differences between X and Y and Z. But hopefully we'll be able to do some more classification with this information. All right, so a pure substance is made up of one ingredient only. They can be made up of elements, which are substances made up of the same atom, or compounds, which are substances made up of the same molecule. So this isn't necessarily a true statement, but it is for this unit. Atoms are the smallest building blocks of matter that we'll discuss in class this unit. We'll actually get a little bit smaller than atoms, but for right now, atoms are the limit. Atoms are insanely small, which is, it's not a bad place to just kind of cut it off right there. We have so little mass here, but they are all abundant. Everything you see in front of you is atoms. Even the stuff that you can't see that's between you and what's in front of you, like the air, those are also made of atoms too. And these are found on the periodic table of elements, which I tried to draw right there. But you got one in front of the room in 209, and you know what it looks like. Molecules, on the other hand, are made up of two or more atoms, and they're held together with these things we call chemical bonds. So it's kind of like attractions, like positive attracts to negative. That's what holds elements and holds atoms together to make molecules. So examples of water or examples of molecules are things like water or propane. Here's propane right there. Here's water. Nitrogen, which is just two nitrogen atoms combined to make a nitrogen molecule. Same thing with oxygen. Two oxygen atoms to make a oxygen molecule. Isopropyl alcohol, you have some experience with that already because that's what we boiled. It has a boiling point of 80 degrees Celsius. And then carbon dioxide is over here. Carbon dioxide is one carbon and two oxygens. Okay, that's it for pure substances. Let's move on to mixtures. A mixture is two or more pure substances, so we can take thousands of pure substances, but anything more than two, and we mix them together. Loosely mixed mixtures are called heterogeneous, and this would be the salami rule going into effect. If you take a look at the salami, you see like chunks of fat and then chunks of meat, and you got the rind, maybe a little peppercorn in there, good stuff, tasty too. But it's not the same throughout. It is different in little places here and there. Sometimes you have to look closely too to see what a heterogeneous mixture is. The other type of mixture is called a homogeneous mixture, and this is when two or more pure substances are mixed together, but they're mixed completely. That's a key word there. So they're really ground up and really blended together, and this would be the example of the bologna example. All right, I thought it'd be a good time to just stop and just freeze for a second and just tell you a quick story, because when I first started teaching, I had these wonderful, huge ideas that just never took off. And so one of them was a game show that I pitched to a few networks, and for some reason or another, it just didn't catch. It was called Heterogeneous Mixture versus Homogeneous Mixture. Come play the game that everyone's talking about. Okay, yeah, and I get it now why it didn't work. But let's play a little bit. So let's have you just write this down right now. We've got Garden Chunky Prego. Now I just want you to guess heterogeneous or homogeneous. So Garden Chunky Prego, salt water, chocolate cake batter, frosted whipped topping, latex paint, and this brick. Okay, you can pause it, and then at the end of the video, we'll go through the answers. So let's keep talking about homogeneous mixtures. These can be classified based on the size of the particles that has mixed into it. So we have all sorts of different types of these mixtures, and we can classify them by being really, really, really well mixed with really, really, really small particles, or kind of sort of mixed with really large particles. So the first type of mixture is called a suspension. Now the particles are small, but relative to the mixture, they're pretty big. And we're talking about maybe half a millimeter, something that you can definitely see with your naked eye. Even a tenth of a millimeter, maybe even a hundredth of a millimeter. Really small but very visible particles. And because they're this large, they're dense enough to be pulled down to the bottom by gravity. So they can be pulled out of suspension by gravity. Here we have some examples of suspensions. Just two, like mud, or this is yogurt, maybe it's sour cream, I'm not sure. But you can see the liquid down here that's separated from the rest of the yogurt. Now you know what happens when you just let mud sit. It will end up, the water will go to the top, the mud will go to the bottom, or the particles will go to the bottom. So basically anything that you need to stir before you use it, that is a suspension. So the next one is a colloid. A colloid, the particles are much smaller. They're about 1/1000th of a millimeter, which is also called a micrometer. And let me just draw that out. A micrometer looks like this. You kind of see there's an M there. It's Greek. So this is a mu, and what I'm trying to draw with that U is a mu. So a micrometer is 1/1,000,000th of a meter, or 1/1000th of a millimeter. Now, colloids are opaque. They scatter light. So when you have, and I'll have to show this to you in class sometime, but if you have a colloid and you shine the light through it, that light will scatter because it'll hit those particles and it'll fly off those particles, and the light will scatter. And so that makes it opaque. It means you can't see through it. This is called the Tyndall effect. So examples of colloids, things like nacho cheese, things like, foams from soap dispensers. Clouds are actually colloids. They're these little bitty water droplets. You've seen water droplets like that when it's very misty out. Those are the same really fine particles that make up clouds. So these really fine particles that are suspended in a mixture are colloids. Lastly, and these are the smallest particles, this is a solution. So these are the best mixed homogeneous mixtures. You can't be any more mixed than this. In fact, like we said that the suspensions would get unmixed, colloids kind of get unmixed by gravity. These do not. Solutions do not. You can see that we're going to the 1/10,000th of a micrometer. Okay, where colloids were like 1 micrometer. These are way smaller than that. And we're talking about basically atoms and molecules. So these particles do not unmix. Okay, they due to natural forces they don't unmix. They don't get out of mixture. And then back to what we were talking about when we showed light through a mixture. Solutions are translucent, so the light particles do not bounce around. They go straight through a solution. So some examples of solutions, we've got medicine, like if you ever had an IV bag that's mostly water with a little bit of medicine in it. It's a nice dilute solution. Coke, soft drinks, Gatorade, those are all solutions. Even your tap water, when it comes out, it has some minerals dissolved into it, making it a very, very dilute mixture. All right, let's review. Matter can be classified as a mixture or a pure substance. Pure substances can be classified as elements or compounds. Elements that are made up of atoms, and compounds are made up of molecules. Mixtures can be classified as heterogeneous or homogeneous, depending on how well they are mixed. And finally, homogeneous mixtures can be classified as suspensions, colloids, and solutions based on the particle size that is being mixed. Okay, that's it for today. We've got, have a good night. Ha! Fooled you. You thought I was done. I'm not. Actually, what I want you to do with this now, let's change the game up a little bit. I definitely want you to think heterogeneous versus homogeneous, but when it's a homogeneous, I want you to think, is it a suspension, a solution, or a colloid? Press pause, fill it out, and then we can go. Okay, we'll try writing this out here. So Garden Chunky Prego, this is heterogeneous. Salt water, this is a homogeneous solution. Chocolate cake batter, that is going to be, well, if you let it sit, it will separate. So if you let it sit, you mix it up and you let it sit for an hour, it's going to be homogeneous, and it's going to be a suspension. Okay, frosted whip topping, Cool Whip, is going to be a homogeneous colloid. You can't see through it. If you could, it would be a solution. Latex paint. Who's ever painted before? You open up a can of paint, and you have to do what to it? Stir it. Yep, that's right. It's a homogeneous suspension. And finally, this brick, what do you think? This brick doesn't look the same throughout, so it's going to be heterogeneous. Now, you might be saying, well, it's made of mud. Yes, bricks are made of mud. But some of the particles, when you cook it, they clump together, and you start to see these different patterns on the brick. No two bricks are ever the same, by the way. That's it for tonight, and I hope you have a good day. This kind of went a little bit long, but I hope you understand. Have a good night. Bye.